Welcome to Bedtime Astronomy. Explore the wonders of the cosmos with our soothing Bedtime Astronomy podcast. Each episode offers a gentle journey through the stars, planets, and beyond, perfect for unwinding after a long day. Let's travel through the mysteries of the universe as you drift off into a peaceful slumber under the night sky. Could life thrive beneath Mars' ice? New study explores the possibility. Despite decades of exploration, no direct evidence of life on Mars has ever been found. However, a new study from NASA offers an intriguing possibility. Microbes could potentially survive beneath the surface, in pockets of meltwater hidden under Martian ice. This study, published in Communications Earth and Environment, suggests that sunlight penetrating through the surface ice on Mars may create environments where photosynthesis can occur, much like what happens in frozen environments on Earth. Water is essential for life as we know it, and on Mars, most of the water that still exists today is in the form of ice. Mars is known for its polar ice caps, but recent studies have identified large amounts of frozen water even in the planet's mid-latitudes, trapped just beneath the surface in frozen layers mixed with dust. This ancient ice, which likely formed during past Martian ice ages, could hold clues about whether life might have been able to survive on Mars or might still exist there today. The new NASA study, led by a diffeer color from the Jet Propulsion Laboratory in Southern California, uses advanced computer models to simulate how sunlight interacts with Martian ice. The team's findings suggest that enough sunlight can penetrate through the dust-laden ice on Mars to support photosynthesis, even at depths of up to 9 feet, 3 meters, beneath the surface. These shallow pools of meltwater could provide the right conditions for microbial life, similar to environments found in Earth's glaciers and ice sheets, where microorganisms such as algae and cyanobacteria thrive in tiny pockets of water within the ice. If we're searching for life anywhere in the universe today, Martian ice exposures are probably one of the most accessible places we should be looking, said Culler, the lead author of the study. Mars has 2 types of ice: frozen water and frozen carbon dioxide, also known as dry ice. For this study, Culler and his colleagues focused on water ice, as it is more conducive to life. This ice is believed to have formed from ancient snowfalls, which were mixed with Martian dust and accumulated on the surface during ice ages in the planet's history. Over time, the snow compacted and solidified into ice, still carrying within it the dust particles that initially fell from the Martian sky. These dust particles are key to the study's findings. While dust can block sunlight in deeper layers of ice, near the surface it plays a crucial role in generating heat. Dust absorbs more sunlight than the surrounding ice, causing localized warming that can melt the ice just below the surface. In certain areas, this could lead to the formation of meltwater pools, potentially creating habitats where life could exist, shielded from the harsh conditions on the surface. This process is common on Earth, explained Phil Christensen of Arizona State University, one of the study's co-authors. On Earth, similar environments can be found in cryoconite holes, small meltwater pools within glaciers that are formed by dust particles absorbing sunlight. These pockets of water provide a habitat for a wide variety of microorganisms, including photosynthetic algae and cyanobacteria. The surface of Mars is a hostile place for life. The planet has a thin atmosphere, composed mostly of carbon dioxide, which offers little protection from harmful solar and cosmic radiation. The lack of a magnetic field, which on Earth shields us from the sun's charged particles, leaves the Martian surface exposed to these dangerous rays. Furthermore, the atmosphere is so thin that any surface water would quickly evaporate or, more likely, sublimate, turn directly from ice into vapor without passing through a liquid phase. However, beneath the surface, these harsh conditions are less extreme. Ice layers just a few feet below the surface could provide enough insulation to protect meltwater pools from freezing solid or evaporating, while also blocking harmful radiation. This makes these pockets of water a potential haven for life. Even though Mars' atmosphere is too thin for surface water to persist, subsurface ice provides a protective environment where water might remain liquid for extended periods, especially if warmed by dust particles within the ice, explained Christensen. This insulation, combined with sunlight filtering through the surface, could create the right conditions for life to survive, or even thrive, in these subsurface pockets. The idea that life could exist in these Martian meltwater pools is based on the assumption that photosynthesis, a process used by plants, algae, and some bacteria on Earth, could occur on Mars under the right conditions. Photosynthesis requires sunlight, water, and carbon dioxide, all of which are present on Mars, albeit in different forms than on Earth. On Earth, microorganisms like cyanobacteria use photosynthesis to convert sunlight into energy, releasing oxygen in the process. These organisms are found in some of the most extreme environments on our planet, including the ice-covered lakes of Antarctica and the high-altitude glaciers of the Andes. In these environments, sunlight is able to penetrate the ice, providing the energy needed for photosynthesis, even in the near-freezing water. The NASA study suggests that a similar process could occur on Mars. The team's models show that sunlight could penetrate up to 9 feet below the Martian surface, reaching potential pockets of meltwater and providing the energy needed for photosynthesis. While the amount of sunlight on Mars is only about half that of Earth, it may still be enough to support microbial life in these icy pockets. One of the key factors that could allow for the formation of meltwater on Mars is the presence of dust within the ice. Dust particles, particularly darker ones, absorb more sunlight than the surrounding ice, causing localized warming. On Earth, this phenomenon creates cryoconite holes in glaciers, where dust particles sink into the ice and generate small pools of meltwater around them. On Mars, dust mixed with ice could have a similar effect. As the dust absorbs sunlight, it could warm the surrounding ice, causing it to melt below the surface. This melting would occur not from the top down, as we usually think of ice melting, but from the inside out, creating small pools of liquid water beneath the protective layer of ice. This is a well-documented process on Earth, said Christensen, referring to the way dense ice can melt from within. It's like a greenhouse effect, where the ice traps heat and allows it to build up, creating pockets of liquid water inside. The NASA study expands on previous research by Christensen and others, who used computer modeling to show that liquid water could form within dusty snowpack on Mars. Their new findings suggest that these meltwater pools could be deep enough and warm enough to support photosynthetic life, at least in theory. While the study provides an exciting new perspective on the potential for life on Mars, much work remains to be done. The next step, according to Culler, is to recreate Martian ice conditions in a laboratory setting. By studying how dust and ice interact in controlled conditions, scientists hope to better understand the potential for meltwater pools to form and whether photosynthesis could really occur in these environments. In the meantime, researchers are mapping out the most promising locations on Mars where subsurface water ice might exist. These regions, particularly in the Martian mid-latitudes between 30 and 60 degrees, are prime candidates for future exploration. Potential robotic or human missions could target these areas to search for signs of life, either by drilling into the ice to collect samples or by using more advanced instruments to detect water beneath the surface. If there is life on Mars, we're going to find it in places like this, said Culler. We just need to know where to look. As the search for life on Mars continues, studies like this one are helping to narrow down the possibilities and refine the strategies for future exploration. While Mars may seem like a cold, barren world, beneath its icy surface there may be hidden pockets of water, potentially teeming with life, just waiting to be discovered.